going to be looking off in the wrong direction.
That's fine.
Of course, this is the moment I notice I have half the software on my computer open, so I'm closing all of it.
Okay, I'm going to do a shameless plug here for our good friends at the Year in Space. Let's see if I can go full screen here. Hold on. Boom. Year in Space. Check it out. So it was like,
Cool.
yeah. Oh, look at these recommended websites. That's a good one. I like that one very much. We got like Apollo 14, and we got all about Pluto, Spitzer.
All the important websites.
Yeah. Series. And planetary bodies in the solar system. Cool galaxies. Anyway, if you haven't already got one,
Get one.
yeah. And we promote them like crazy with Universe Today, and they don't pay us any money. So I know that sounds baffling, but I just love this calendar. And Steve, who runs the company, is great, and he reaches out to us every year and gives away a whole pile of them to Universe Today readers. So instead of like taking money from them, we just get them to give away as many copies as they can stand to our to our readers. That's how we do that. We pass the savings on to you. And then I didn't have it in the show, but now I have one here. Let's see.
Cool.
I don't know. Is that coming through? It's probably not coming through. But
The Night Watch or the Death from this?
No, here, hold on. So this is the desk calendar, which is cool. I haven't even opened it up yet. And then, of course, Nancy's book.
Yes.
Which I didn't have in the previous show, which is kind of ironic because we had Nancy on the show. But
irony happens.
Yeah. And then, of course, I reorganized my, those right there, my 3 Parsec awards, just to
I know.
Just to keep things, nice and balanced. Apparently, your fish tank is increasing steadily. You have more fish tanks now?
No, I rearranged the fish tanks. So the fish tank that is off my left-hand shoulder, which apparently has... Oh, I know what that is. So let me rotate the camera. So this fish tank, which is substantially larger than the one that used to be behind me, was in a different place in the house, and I just consolidated fish tanks. So instead of having a small fish tank behind me, I now have a much bigger fish tank, and there are fewer fish tanks in our house.
David Dunn's asking, do you have a book?
Me? Not yet.
Don't you have like a goodly portion of a textbook?
Yes, I do. I need to finish writing that.
That counts.
Come on. I have a dog that's driving me crazy.
I know. The dog is like got opposable thumbs now. Let's see.
So, for those who haven't seen my dog, who's about to get booted from the room.
Oh, look
This
at
show
those cute eyes. How could you do that?
This show is the one thing between him and the dog park, and he knows it.
Oh, really? It's just
Yes.
like one step. As soon as the show is done, that dog is at the dog park.
So he knows the next time I walk down the stairs, it's time. We get to go to the dog park.
Is it my voice? I don't know. No, because he can't hear me. So how does he know? How does he put all these clues together?
Time of day. It's getting to be the time of day when we go to the dog park. And dear God, he's going crazy.
You want to give him the boot now?
Yeah, I am.
Okay.
Normally he'd lie quietly, not today.
No. Look at him. Oh man, he is all up. Really wants your attention. Walkies. I'm gonna say hi to a bunch of people. I'm going to say hi to Adam Synergy, Elise Robies, Arnold Post, Dave Regan, Susie Murph, who's pretending to be Astronomy Cast, David Dunn, Dusty Reichwin, Eric W., Jill Sabrin, G-Man351, Guido Bibra, Helen Bjorkog, James Haney, Jeremy Nowak, Jim Meeker, John Suffield, Curry the Vegan, Larry Beckham, Marco Petitjean, Michael Jobin, Nancy Graziano, Richard Clark, Sergio Botero, Sylvan Westby, Tech Tang, Thomas Tranneker, Tom Van Scotter, Altied, Vendetta Vegan, Unisofree, and Zapfan. Hey, everybody. Welcome to Astronomy Cast. The last Astronomy Cast of 2016.
Yeah.
But not the last Astronomy Cast of the ever. We
No.
have many years. We've been at it for 10 years. We got many more years. What was I going to say? Right. I was going to give a quick announcement. One announcement is check out Astronomy Cast, University tomorrow. We will begin our giving away the 2017 101 Astronomical Events book written by Dave Dickinson of Universe Today fame. Free book, free ebook, 200 pages, free. Just come grab one. So that'll go live tomorrow once I've finished my final edit on it, which is cool. And big thanks to David for writing it, and big thanks to all the photographers who kicked in some pictures. It's going to be fun. And hopefully that'll give you all a whole year in advance to plan your outings, especially the eclipse.
Yes, that's very true, and we can't wait to meet all of you that are coming out to St. Louis. That are coming out to St. Louis to join us for the Astronomy Cast, watching the eclipse.
People are saying your mic is a little hot compared to mine, so I wonder if I want to make
I'll
mine. No, because you want to make it sound good. I'm gonna bring either me up a little bit. Can you do some more talking?
Maresy dotes and dozy dotes and little lambsy divey.
You're just loud.
Maresy dotes and dozy dotes.
Yeah, that's okay. We're good. We're good. I think we're a little quieter now. Man, audio is just another rabbit hole mystery device. Cool. So 2016 sucked. Goodbye, 2016.
Yes.
Good riddance.
Yes. The most commonly uttered phrase on my Facebook feed is one I cannot say on our family-friendly show.
Yeah. Yes. Agreed. Carrie Fisher, John Glenn. Yeah, no, it's been a bad one. Anything we should mention news-wise related, or should we just push on into this thing we call Astronomy Cast?
Yes, we shall push on. We shall endeavor to move forward.
All right. Hold on. Okay, I'm ready. Here's my intro. Ready to click record.
Yes, that's a thing.
Hey, to the people who who are seeing this live for the first time, don't forget, if you want to be notified when we do these shows live, just click on the little notification bell in your subscriptions on YouTube, and then you'll find out when it happens. And as you will learn, there is like twice as much show. So if you just listen to Astronomy Cast and just get it every week as a podcast, the one that we do live is actually pretty much twice as long, and we answer your questions about space astronomy. So,
but we're not recording yet, so they don't know that.
Well, yeah, I know. There's people watching right now, though.
Right, but we should say in the audio.
Should I do that in the actual show? Sure, I will do that. I will do that.
Yes. And I'm going to arrange. I should announce that in the actual, which we should be recording.
We will record that shortly. Yes, that will happen. Okay, fine. Man, let's get started then. Whoops.
Press record?
That's not going to go there. Okay, I guess I'll put that there. All right. Tell me when you're ready to press record and say hello to Chad, who is coming back in 2 weeks.
Good. I am ready to press record.
I have also pressed record.
Hi, Chad. We can't wait to have you back.
Hello, Chad. I wonder if my audio is a little hot. Anyway, all right, I'm just going to get going. Here we go. Astronomy Cast, episode 433, Volcanoes of Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Good. The final episode of 2016. I guess, but for those who are listening to it, it's probably already 2017. So
It's true.
Happy New
It's
Year.
true. And if you haven't heard this already, that means you're listening to the audio show and you are missing out on all of the craziness that goes on with our pre-show and with our post-show Q&A over on YouTube.
Yeah, our Astronomy Cast has now sort of become about twice as long. Every episode that we do it live on Fridays at 1:30 Pacific time on the YouTubes, and we then do the show. It takes about half an hour, and then we stick around and answer your questions about space and astronomy, and we just chat for another half hour. So if you want to get more Astronomy Cast, you can come and check that out. Just search for Astronomy Cast on YouTube and you'll find it. And if you want to be notified when we do our live show, just click on the little notification bell and then you'll get that announcement.
And so we hope to see you live where you get to see how the sausage is made and enjoying the insanity.
Yeah, and you get to have all your questions answered. We just stick around and answer them. So that's the deal. You want to watch us live, we'll answer your questions. Mars is a world of extremes. This unassuming red world is home to the largest and tallest volcanoes in the entire solar system. In fact, it's not even a close contest, with Olympus Mons rising 22 kilometers above the surrounding plains, more than twice as tall as Mount Everest. How did Mars get such big volcanoes, and how active is the planet today? All right, so let's go and sort of let people know. Let's talk about some of these volcanoes as they exist today, and we'll kind of blow people's minds about the size and scale of these things.
So you already started it with Olympus Mons, which is more than 20 kilometers high. It's caldera, that pit that on cartoons you're always throwing someone sacrificially into. That caldera pit by itself is 3.2 kilometers deep. And this is the biggest volcano, the biggest mountain, the biggest from the base of its formation to the top where it's literally making it something that comes up over the edge of the planet and is highly noticeable. Olympus Mons is just the biggest geologic feature in our solar system.
Did they know about Olympus Mons before the spacecraft explored it? It was visible from Earth. Okay.
So you can readily see the entire Tharsis region. So this is that volcanic region where you see a stripe of three beautifully aligned volcanoes and then Olympus Mons hanging off to the left in most NASA imagery. So north up, we have west is where you have Olympus Mons, and then you have this alignment of three volcanoes from west southwest or south southwest, I guess, up to north northeast.
And each of these other volcanoes on their own are incredible monster volcanoes.
Yeah, and the one that gets me is the Arisia Mons. It's caldera. This is the episode where I'm going to twist my tongue on everything. Arisia Mons, which is when you're looking at them, the one in the lower left. It's 130 kilometers across on its caldera. So just that hole in the center, for those of you who speak imperial, that's 81 miles across. It's 1.3 kilometers deep. So just the caldera is an extremely impressive feature.
I'm sort of looking at a picture here on the internet, and you could just barely fit Olympus Mons within France. All of France. It's just barely fits.
The Tharsis region on Mars, which is a pretty good sized world, 25% of its surface is this Tharsis region. So a quarter of the surface of Mars is this one volcanic activity center. For comparison, 29% of the Earth's surface, land. So there is almost as much of the surface of Mars, percentage-wise, that is one volcanic region as there is land on all of the planet Earth.
That is a large region. So, and one of the things as well, people always say like, oh, it'd be so cool to stand on the top of Olympus Mons and see the valley below. Like the view from the top of Olympus Mons would be amazing, but the it's so big that the planet curves away faster than the mountain. So you literally could never see the valley below if you're standing on the surface of Mars. You would just see the flank of the volcano and following the curvature of the planet away from you. There's the view from the top of it would be, I guess, okay, but all you would be seeing is just more volcano in all directions. You would not actually be able to see the rest of the planet, which is just super mind bending. Yeah.
And these are mind-blowingly large volcanoes, in part due to the fact that Mars has significantly lower gravity and significantly lower atmospheric pressure than we have here on Earth. So when you combine these things, you end up with giant shield volcanoes that don't act like shield volcanoes here on Earth. So if we had been able to be around when these things were doing their whole eruption thing, we would have seen at one point on the Elysium Planitia a volcanic plume the size of Oregon. So this one tongue of lava, the size of Oregon. And we also would have seen massive ash plumes that aren't normally associated with shield volcanoes here on Earth. And this is just due to the combination of you can end up with a different gas load inside lava of this viscosity, this runniness, all sorts of crazy things happen. And these are also hotspot volcanoes, which we do have here on Earth. These are the kinds of volcanoes like Hawaii is this kind of volcano. But with the hotspot volcanoes on Mars, you don't have a big bubble of lava that's directly below the surface. You have it coming up from much deeper down. And when it goes, it seriously goes and goes and goes and goes and goes. So you don't end up with these sporadic Icelandic type volcanoes that go off every once in a while briefly. You end up with millennia of going off.
All right. Well, let's talk about these two ideas that you just mentioned here. One is that the volcanoes on Mars are shield volcanoes, and the best example of that, of course, is the volcanoes of Hawaii, which are gigantic shield volcanoes. Mauna Kea, Mauna Loa. What causes a shield volcano?
The best way to think of it is as it goes off, it just has the lava just flowing outward, forming layer upon layer upon layer that builds up over time. And what's cool with this building up through layers that you see on Mars is because you do have the lower gravity and you have a different viscosity of the lava just flows slowly for a long time, and you end up with these very shallow inclination angles, which is a fancy way for saying it wouldn't be terrible to bike ride up one of these things because it's like a 4-degree incline. A lot of these volcanoes here on Earth, if you've ever gone up to the top of Mauna Kea down in Hawaii, it is steep. The engine of your vehicle is hating you. You don't even want to climb this thing. Here you're looking at much more shallow grade mountains.
But the idea is very similar, right? That you've got this it's a certain kind of lava it's producing that's very viscous. Right, I think that's the term, right? Not viscous. Hold on a second. The one that's not thick, not less syrupy, right? So that it flows out and sort of spreads in these kind of even patterns and goes a long way when it comes out of the. It has a low viscosity when it comes out of the caldera and flows down the side of the mountain. It goes for a long, long way, and so it's like it's painting lava onto this volcano, just layer by layer by layer. But the other thing is that they're sticking around. He said it's this hotspot idea, but they're sticking around for a tremendous amount of time. And so over the hundreds of millions, potentially even billions of years, Mars has had plenty of time to get this lava out onto the surface and really to spread it out across the Tharsis bulge.
One of the more amazing factoids I've run across about the
The
Tharsis bulge,
Tharsis bulge.
about the Tharsis bulge is it might be 4 kilometers deep in just layer upon layer of multiple generations of volcanoes. This bulge itself formed about 3.7 billion years ago. So this was during the Noachian period. And as it built up, there was an earlier generation of much smaller volcanoes, just kind of all over the place, before we ended up with this triumvirate of volcanoes that form that main ridge line, and then Olympus Mons off to the side, which is a little bit younger. So you have this history of, since the earliest days of Mars, this was going on. And as we talked about a little bit last week, the formation of the Tharsis bulge led to the rifting apart of the planet's surface in other places.
Yeah, it cracked right open to let this sort of bulging and upwelling of volcanic material had an impact, and and geologists are still understanding and realizing the implications of what this did to the planet's history even now, and some the spacecraft are helping to get a better sense of this as well. Are the volcanoes dead? Is Mars geologically dead?
We think so, but we don't know so. So here's where spacecraft like Maven becomes so important. I actually have to flip through my notes because I will screw up the chemicals. So there was thought from counting craters. Folks like Gerald Nocum and his team have been counting craters, and it looks like by crater dating, youngest volcanoes that folks have been able to identify are about 2 million years old. But there's this methane that keeps cropping up in the atmosphere of Mars. And if you see methane, then you either have life or you have geologic processes. So you start looking for evidence of these two things and ways to distinguish between them. Well, if you have volcanism in the form of happily erupting volcanoes, then you'll have not just the methane, but you'll also have sulfur dioxide. And studies that have looked in detail for the sulfur dioxide have not found it at all. So that seems to indicate that we don't have active volcanoes going off. Now, what's interesting is there's other ways that the environment can generate methane. Another factoid I learned prepping for this show is you can actually take carbon dioxide and water, and during an electrical storm, the electric charge in the atmosphere and the discharge of that electricity can lead to the formation of methane. And then it deteriorates over time. But this is a world that has magnificent dust storms, and that magnificent dust storm can generate lightning shows.
So let's talk a bit about the reasons why. That'd be crazy. Lightning, that would be just amazing. Let's talk about why Mars has such big volcanoes. So there's two real big processes going on here. One is the low gravity. So you can just build things bigger. Mount Everest could be, one over bigger, 1 divided by 0.38 times bigger, right? Just in terms of gravity, because Mount Everest is like as big as a mountain can be on Earth. Like you pretty much can't get any taller than Mount Everest. But if you decrease the gravity, you can have a bigger mountain. But Mars doesn't have any plate tectonics.
Not the way we think of it. So here on Earth, I mean, we readily joke that California is trying to visit Alaska as the plates move. We see the Rift Valley in Ethiopia, where Africa is literally tearing itself apart. There are distinct plates on Earth that are each doing their own thing, moving in their own direction, causing massive disruptions on the surface of the planet when things that are sort of held together, like roads, cease to be held together because the earth beneath them shook.
Yes, this is my world.
This is our world.
Yeah.
Now, on Mars, we don't have all of these distinct plates. There are perhaps two plates, maybe kind of, on either side of the Marin, on either,
Marianas?
yes, on either side of Valles Marinaris. Those plates aren't well separated, aren't extremely distinct, aren't moving in the ways we're used to. So what you end up with instead is this is a world that had a molten core, still has somewhat of a liquid core, we believe, and heat has to escape. And via various convective forces, you end up with these hot spots, and these hot spots eventually eat their way all the way through the planetary layers until they come out the surface. And this leads to prolonged volcanoes in single spots instead of these rifts like we see on Earth that are dotted with volcanoes all along them.
Yeah,
So,
and anyone who's been to Hawaii, you've experienced that, or you've seen, Kauai is the old one, and then Oahu is a little younger, and then Maui's even younger, and then I forget which side, the western side of the Big Island is older, but then there's active volcanoes, and that hotspot, the Earth is moving above that hotspot, and so it's constantly creating new volcanoes as it goes. But really,
whereas we also have the Pacific Rim and the area along, for instance, around Naples in Italy, these different areas on the planet where you have strings of volcanoes. Japan has a string of volcanoes. Alaska has a string of volcanoes.
I live in a string of volcanoes.
You do live in a string of volcanoes. And these are very much generated by places where either two plates are, one is ducking under the other, or they're diverging apart from one another. This is a completely different kind of volcano. Mars does not have Iceland-like volcanoes. It has Hawaii-like volcanoes.
Yes. And so, I mean, I had heard that it is like maybe possible that Olympus Mons could erupt again at some point. Do you think? I mean, probably not in our lifetime, but is it between now and when the sun destroys it?
I don't think we know enough yet. And
Yeah.
this is the cool thing about why we keep doing science is we're still learning to fully understand volcanoes. If we understood them better, we'd know when Katla is going to go off next. And I am one of these people who's just waiting for that next gigantic Katla, earth cooling Icelandic volcano eruption that unfortunately will do bad things to travel. But I'm going to ignore that and look forward to the cooling properties of what it will do to the atmosphere. We still don't know these things. And we also don't have a really good understanding of the interior of Mars. It isn't a world that we've mapped out seismically to the degree more. Wow, my audio file just totally crashed.
I heard something go funny there.
Like Audacity crashed.
It'll restore it.
Let's hope.
It will. I trust in Audacity.
Reopen.
Just make sure you recover the file.
Some projects were not saved properly. Recover projects.
The answer is yes.
Okay. Yes, I pressed yes. Okay, I'm going to go to the end of this and listen. Sorry, audience. This is me going, why is it only showing 11 seconds of audio?
Yeah, go to the end of it and then just start your recording again.
Except it's only showing 11 seconds of audio. Wait, there we go.
And I'm just going to let mine continue rolling.
I'm going to save this. Save project as.
Yeah.
And then I'm going to start a new file just to be safe.
Okay.
This is 433?
Yes. So I guess 433 part 2. And then Chad can just mix them back up. We'll give him a 3, 2, 1 countdown just to make it a little easier.
Yeah, sorry, audience. There's nothing scarier than having your audio software go boink with violence. Okay.
Say what?
I am now recording
All right.
it
Yep.
Yes, it's the correct mic. Okay. 1, 2, 3 for Chad.
Sure. One,
1,
two,
2,
three.
3. Sorry, Chad, that
He
kind
can
of
he can line it
bugged.
up. He'll make it sound okay.
Okay.
Please continue. Do you
I have
remember what
no
you were
clue what
talking
I was
about?
saying. No.
Well, we were talking about the future potential of volcanoes on
Yes.
Mars.
Okay. So what's kind of amazing is we haven't really mapped out Mars seismically the way we'd like to. We haven't been able to distribute the kinds of probes all over its surface that will detect all of the wiggles and jiggles, the P waves and S waves that pass through the planet when it gets hit by small asteroids, when we hit it with probes, because this is a thing we do.
Right. So this idea, like the seismograph. I mean, we're so familiar with this little line that go, the little pen that's drawing on a line that's going, and it's sort of drawing out the waves, the various shaking that the ground is doing. One of these does not exist on the surface of Mars, and better yet, you need multiple of these on the surface of Mars,
Right.
mapping out as events happen.
And we just don't have that. And since we don't have it, it means that we don't have this deep understanding of where are the thick areas, where are the thin areas, where's their liquid, how does vibration transfer through the surface. So we want to know these things. And we know that Mars is constantly getting hit by things, not just the things we hit it with, because we see the new craters forming. And this is opportunity to learn about the inside of the planet. And with that information, we'll be able to predict, is the volcanism off forever? Is the lack of volcanic activity for 2 million years a sign that, yeah, she's done. She's done.
But this, I mean, you
Yeah.
talked about this brief, earlier in the show, this idea that we're searching for methane in the atmosphere of Mars. Now, of course, the sort of one exciting idea about this is that it is life, and that there is active methanogens on the surface of Mars, and they're producing methane, and that's super awesome. But the other idea is that there is still some kind of active volcanism that's going on. It's producing, volcanic outgassing, and that means that the interior of the planet is still kind of, partly alive, mostly
And
dead, but partly alive.
and one of the things that we see on Mars that was part of the evidence for plate tectonics on Earth is this striping of polarity in magnetic fields that are found fossilized in the rocks on Mars. So just like on Earth, you'll find things that have intrinsic magnetic fields that aren't all lined up the exact same way, because those rocks and their magnetic fields were locked into place when the pole had a different alignment than it currently has. We see similar striping of magnetic fields on Mars. So we know that dynamics was there. And it's neat to think about these things, but again, we still haven't found that sulfuric dioxide that's evidence of active volcanoes. The place to go and look is the Lucian Planitia. This is where the most recent signs of volcanism are. And again, tongues of lava the size of Oregon. It's kind of cool.
One of the kind of sad things about Olympus Mons is that it's a pretty terrible place to actually visit for spacecraft. It's so high up that there's no atmospheric, there's almost no atmosphere that can be used to use the aerobraking the way they do with the current spacecraft. And as well, it's covered in dust. Thick
And
layers of dust that kind of collect as those dust storms go around the planet. So
right.
so it'd be a pretty terrible place to try and visit and explore and rove through.
Yeah, so you'd want to first of all try and land inside the caldera, and second of all, uh, Yeah, you have to use retro rockets. It's the only way you're going to land on one of these things. There's just not enough atmosphere. So it's tricky. Or we just need to build much faster moving rovers and land one off to the side and send it climbing. But we're not there yet. We still need a whole lot of self-driving car research to be done.
Well, I just imagine some rover, like some kind of monster truck rover with great big tires, trying to blast its way through this really deep, fluffy regolith as it makes its way up to the caldera and to peer over the edge. While standing on the caldera and looking towards the plains, towards the valley, would not be that interesting. Looking into the caldera would be an astonishing perspective. That I would
Right.
like to do.
Yeah, if you've ever been to the Grand Canyon, think Grand Canyon on all the steroids. This is kilometers deep. It's just huge. It's awesome and totally worth exploring.
So we're familiar with the main one, obviously Olympus Mons, then the other three, which again, each of which would be the largest volcano in the solar system if it wasn't for Olympus Mons. Like they just, the next, I think the number two is like 20 kilometers tall. While Olympus Mons is 22, the second one is like 20 kilometers tall. So these are gigantic volcanoes.
Yeah.
But is there other volcanism on other parts of the planet? Do we only see it here, or are there other regions
No.
that have some evidence?
No. So the two big regions are the Tharsis bulge and the Eleusium planitia. But one of my other most favorite random things in the solar system in terms of, wow, that's a thing that happens is Alba Mons. This is a volcano that is, to use the big words, antipodal to the Hellas impact. This means that if you take Mars and you do the whole digging to China kind of thing and put a line straight through this three-dimensional
Yep.
object.
Yep.
On the other side from Hellas impact, you have this volcano. And it's thought that possibly the seismic waves of this magnificent impact actually caused a volcano to go off on the other side of the world.
That is mind bending. That there was impacts that big, and that you can just imagine this kind of these waves flowing through and then kind of coming together on the exact opposite part of the planet and then causing this kind of release of energy in the form of volcanism. This is thought that this kind of event had happened on Earth in the past as well. There's like some regions that were antipodal to large potential impacts as well, like rippled terrain and things like that on the Earth.
And we've had suspicions about some areas on Mercury, but this is one of those best examples of Hellas on one side, cool lonely volcano on other side. I mean, it's not entirely lonely. It's Mars. There's volcanoes most places, but it's striking and it's awesome to think about. Just that all those waves, their energy coalescing to trigger a volcano.
We see those shield volcanoes, but here on Earth we have many different varieties. We have like various cone volcanoes and ones that are composite volcanoes and various kinds. Do we see any more of those? Like those really tall, spiky, peaked ones?
Nope.
We don't see those at all.
No. Well, so first of all, the it, the shield volcanoes have highly fluid basalts, and this is a function of, first of all, you have the magma chamber, which has a set temperature, but then you have not just the temperature that causes the fluidity, but the composition. And it's the composition of Mars lava that is this standard basalt lava that is leading in part to similarly composed, consistent kinds of volcanoes across the surface.
Crazy place. Cool. Well, thank you very much, Pamela.
It's my pleasure, Fraser.
We'll see you next year.
See you next year.
All right.
Okay, now
Stop.
to save
Save.
it.
Don't go anywhere, everybody.
We will be back and give you our full attention once we are done with the random saving, not random, the purposeful savings of the
Purposeful, very
files.
specific saving. Okay. I have saved. I haven't uploaded yet.
Yeah.
Okay, question from Eric W. Are you ready? You saved? You ready? Ready?
I'm
How about
working
now?
on the saving, but go ahead.
Eric W. wants to know, what field of astronomy do you study?
Right now, I am mostly a computational person, where I'm writing software that allows people to do all different kinds of astronomy to do their thing. By training, I did variable stars up until my dissertation, where I was told there's no money in variable stars, go further out, and I studied the evolution in galaxies. So my two concentrations are variable stars, which is an epoch of stellar evolution, and galaxy evolution in different environments.
There you go. What I'm gonna we did this and I'm gonna totally sort of, this is gonna come out of nowhere, and I apologize in advance. We just talked about the big stories of 2016, and we sort of all shared a bunch. And I can give you some primers if you want. But what big stories or big story last year kind of really gave you the feels, if you know what I mean? Like, which one
Oh
really
man.
kind of excited you? Which one sort of made you, sort of blew your mind? Which one really felt like we pushed forward our knowledge and understanding of the universe?
So the one that still has me going, this is a really cool puzzle, is this irritating star that they keep saying has alien megastructures
Yep,
around it,
yeah,
is we don't know what it is.
yeah.
And things that are utterly perplexing. Those are the things that I like the most, and that one's utterly perplexing.
We're really fortunate with the Weekly Space Hangout because we have Kimberly Cartier, who is one of the astronomers on that team. She's an exoplanet observer, and she's one of the people on that team that sort of helped find it and discuss it. And so we get the news first on the Weekly Space Hangout from her, which is great. Um, yeah,
And
it's
the one that
awesome.
gave me the feels in terms of like the my heart is going to explode was the news story that there were vibrational anomalies during vibration tests on JWST. That one, I'm like, please fix this, please fix this.
Anomalous vibration. Yeah, yeah. We talked about
Yeah,
that as well last week, which is that there's anomalous vibrations. So it
yeah.
shook in all the ways they were expecting, and it also, something was rattling in a way they were not expecting, which is great. So I think for me, we didn't bring it up. We talked about SpaceX and, how we don't want Elon Musk to break our hearts, how he's taken all of our hopes and dreams and for space exploration and just taken it to the next level. But for me, the discovery of a planet around Proxima b was amazing because it is the closest possible planet that can ever be discovered, unless there's some brown dwarf that we're not aware of that's a little bit closer.
Right.
Essentially, that's it. That's the closest possible planet that will ever be discovered to the
So
sun.
my favorite read over the holidays has been We Are Legion, We Are Bob, which is the stupidest named book ever. And I like totally poo-pooed it based on the title, but people kept
Mm-hmm.
recommending it to me. So I broke down and read it, and it's fabulous. And this actually plays part of the plot point that there are planets so nearby. So go read it. That's all I can say without
Yeah,
spoiling it.
yeah.
It is it's too
But
easy
that
to
is it.
spoil.
That is, I don't know, like that's the landmark, right? Like that, like we have found the closest star to Earth, which is the sun. We found that out a long time ago, right? We can never find a closer star unless we're having a very bad day. But, we have found our closest extrasolar planet.
Don't give 2016 ideas.
2017, to place another sun closer than our own sun. Yeah,
I
that would
I
be cool.
started listening to Lucifer's Hammer yesterday while cleaning and realized I had to stop. I just had to stop and
Yeah.
find something else. And now I'm listening to a book on forensic science because somehow that is much less disturbing.
Um, Jonas Sofri wants to know what our educational backgrounds are. So, well, you already sort of half explained it. So, you are a PhD astronomer, right?
I am. I have a bachelor's in astrophysics from Michigan State University, where I studied RLRs in the field and Cepheids in the field and RLRs in globular clusters, to say it the way Fraser says it.
Nice.
Um,
Globular.
with Dr. Horace Smith. And then I went to the University of Texas, where I got a master's degree working with Edward Robinson, studying the variable star population of the Ursa Minor dwarf spheroidal galaxy. And if you name your dog Ursa Minor, it really confuses people, and I highly recommend it. And then I did my dissertation research on the Butcher-Umler effect in galaxy clusters, working with John Cormandy and Gary Hill.
Man, my educational history is so boring. So when I graduated from high school, I went to University of British Columbia for engineering. Did a year of that, realized that it sucked. Not UBC, just engineering. Me and engineering didn't get along. And then I went and ran software companies, startups. So I was sort of in the internet space. And then about 10 years ago, I went back and got my computer science degree. So my background is all in computer science and in technology. Pamela's the one in astronomy. Of course, the irony that we always think is hilarious is I think I spend more time doing astronomy and she spends more time doing computer science. So it's strange how we've sort of flipped things. But
I do have a lot of coursework in computer science. I'm a lamp stack kind of girl. Give
Yep.
me a good command line and a Unix Linux flavor of environment, and I'm happy.
Have we seen Rogue One?
Not yet.
Nope. But let me explain why. My local movie theater is the worst. And I absolutely refuse to see movies in the local movie theater. And then, so whenever I go to Vancouver, and they've got these beautiful theaters with the really comfy chairs, and I spend the same amount on a ticket for this really great comfy chair, and I watch the movie on a great big screen, and the floor isn't sticky. That's what we do. But I just refuse to watch movies here locally. So sometimes I have to miss them or catch them on video later. So
See, we have a great local theater. We also have a whole lot of college students, high school students, elementary school students, people whose parents want to dump them at the movie theater to
yeah.
get them that expletive out of the house. I live in a small rural town or suburban town, depending on where you're from.
With a nice movie theater.
With a nice movie theater, and all the parents are dumping all of their kids there. So we're waiting for the kids to go back to school.
That could be us. We could have a nice movie theater here. It's just someone just has to spend some money on chairs. That's all I'm saying. And I refuse to give them one more penny. But so when I have seen a movie, I paid dearly.
Yes.
That
you went to the mainland.
No, I either paid dearly because I went to the mainland, or I drove 100 kilometers to the proper theater, or I just sat on this super uncomfortable chair for 2.5 hours, hating every second of it while I watched that movie. So I did it for The Martian, but that's I think the last movie. What was the last movie? No, actually, we went and say Moana, so I saw that.
Oh, the Disney movie.
Yeah, that was really good. My son and I went. Let's see. Are there questions? More questions. Okay, so Claudia Mastroianni is asking, because ratios are hard, web sources differ, which is bigger, Olympus Mons or TAMU Massive? And I guess what they're saying is not which is bigger. Olympus Mons is bigger, but that Olympus Mons is either 25% bigger in volume or TAMU is 25% smaller in volume. Is that the...
Then what? What are the two things?
TAMU Massive, which is, I guess, an underwater volcano that's gigantic.
I don't know.
Yeah.
I have no idea. This is one of those things that you have to Google.
Astronomer, remember?
Yeah. I don't store all the numbers in my head. I do write them on paper sometimes.
Let's see. Extinct submarine shield volcano. Formed about 145 million years ago. it would make it the largest known volcano on Earth, dwarfing Mauna Loa. Cool. We can't help you any more than that. Debus says watch movies online. Yeah, I watch Netflix. We get what we get with Canadian Netflix. Actually, you know what's funny? We get a better selection of stuff in Canadian Netflix's movies than you guys do in the US.
Yeah.
So we got The Force Awakens really early. We got all of the Marvel movies come through our Netflix. So it's actually, for once, we don't get a crappy experience. But then we don't get HBO in Canada. If I'm on Cord Killers a lot, which is a great podcast with Tom Merritt and Brian Brushwood. Anyway, and I constantly am complaining about our lack of choices here in Canada. We don't get Hulu, which I know you get all of your viewing from. We don't get HBO here. So, it sucks.
It's sad.
Mm-hmm. Let's see. Someone's about to get banned. Question from XT8Dob. Is there anything you'd specifically like us to do on the astronomy outreach side of things? So are you asking like what we would like you to do? Or are you wondering what you would like us to do?
So I'm not sure. Are you looking for volunteer ways to educate or volunteer ways to do science?
Or what should in general people share in astronomy outreach?
So I think in general, your everyday person just promoting things like sharing on your Facebook feed when cool, awesome science comes out to try and get people thinking about what we're learning about the universe instead of what we're destroying in the universe, which is what we seem to largely be doing on the surface of our planet. Spread joy through science by there was a great picture from Hubble of a set of gravitational lenses that kind of make a galaxy cluster look like a Cheshire cat. I retweeted this earlier today on my Twitter feed because we all need galaxy clusters that look like smiling cats. So at the most simple level, just share what makes you excited. If you want to get more engaged, look into getting involved with your local astronomy club, look for a Night Sky Network group nearby, get involved in one of these organized groups that will help direct you and get you resources for getting involved. So there's things like we're all trying to figure out how to get people engaged in the 2017 August 21st solar eclipse because it's visible to everyone in the continental United States and swaths of Mexico and Canada as a partial eclipse. And there's going to be a whole lot of people who have a whole lot of misinformation about when it is and isn't safe to look at. There are folks that for some reason think that like it will kill you to be outside during a total eclipse because you'll get cancer. No, not true. So helping to spread information about upcoming events, about one thing Fraser does all the time really well is on those days when like Venus is right next to the moon and everyone's like, oh my gosh, what's that thing in the sky?
That bright star in the sky, yeah.
He like trolls Twitter answering that for people.
Right. Try to get banned by answering the same question 1,000 times. I mean, I think that it's funny. Like our culture is so bizarre because the most popular movies, the most popular of our popular culture is science fiction, is a lot of space themed stuff. Star Wars, obviously, right? And that for every person who loves Star Wars, there's a potential person who loves the underlying science and space of it. And it's those connections between the underlying science and the reality that are where the magic happens. And so things like The Martian, for example, where you take this great story about exploring space, but you base it in reality so that it all rings very true and the science isn't doing it a disservice, I think is some of the most valuable stuff. But it's a strange dichotomy to me that on the one hand, the most popular things in our popular culture are I guess Kim Kardashian, but also the, the space and astronomy themed kinds of topics, and yet people's actual knowledge of these things is fairly low. And I think that's the connection. That's the place where you've got that opportunity, the thin edge of the wedge, for people to be like, oh, I really enjoyed Star Wars, or I really enjoyed Rogue One. Oh, okay, did you? Here's some cool science that's happening right now. There's a moon that looks just like the Death Star. Let's check it out. So I think that there's a lot of stuff like that we can do. I don't know. It's a funny thing that I find that so weird. And then someone's just mentioning here about things like Kerbal video games, right?
Oh
The
yeah.
most popular video games are space themed or
And
fantasy themed, but
and so I think trying to get people thinking about the real science that ties in with the fiction they love. And you and I both go to science fiction and gamer, well, you go to gamer conventions, I don't. We go to science fiction conventions where we get this word out. So like I'll be at the Eurasia Science Fiction and Fantasy Conference in Boston in a couple of weeks. So come see me if you're going to be there. You've gone to Penny Arcade and Dragon Con and others, and this is part of trying to take advantage of the teachable moment. Well, what could it mean that you made the Kessel run in some number of parsecs? What could that mean? Let's talk about the science.
Let's see. Got some more questions here. Okay, Larry Beckham wants to know: can we recommend any other eclipse trips now that the best one is sold out?
No.
No. No.
Everything is selling out. It's kind of like if I didn't live where I lived, I'd be doing one of the ones at one of the national parks. And apparently those sold out years ago. So like Jackson Hole, not going to happen.
I don't know. Has anyone tried to invite you to one of those yet?
No, everyone. It's such a closed. You pick years ahead of time who you're organizing these things with, and you and I picked each other a long time ago, so it works.
David Dunn asks, did you choose Southern Illinois because of the two total eclipses in 2017 and 2024?
No,
No.
I picked it because I used to live in Boston, and it is so much cheaper to live here than Boston.
Still trying to get you into Canada.
It could happen. It could happen.
Let's see. There were some other questions here early on about volcanoes. Let's see here. Actually, Arjun asks, would a black hole have a dark matter accretion disk? Could we detect dark matter annihilations this way?
There's dark matter everywhere.
But would you get an accretion disk around a black hole?
The issue with an accretion disk is it's partially frictionally supported. So you have stuff coming in that can't dive straight into the black hole because of conservation of angular momentum, and then things that are going around end up frictionally heating and compressionally heating, and all of this weird physics that requires collisions to be part of the physics involved. And dark matter is pretty much collision-less, so the physics is very different. So could you end up with stuff orbiting around a black hole? Yes. Would it collapse down into a disk? Probably not.
Right. It's that I always describe it as like when you're in a bath and you pull the stopper on your bathtub, and then the water's just kind of swirling around because it can't get into down the drain fast enough, right? That's the material that's piling up on the outside of a black hole. But as you said, right, you need particles that have some kind of cross section, and right now the thought is that dark matter has literally no or an infinitesimally small cross section, so the stuff just doesn't bonk into each other.
True.
So dark matter is most certainly going into black holes, but it's also not kind of getting caught in their accretion disk in the same way.
Right.
Let's see. James Haney wants to know, does Mars have an equivalent to sea level?
Yes, it's the average height of the surface. This is part of how you get at the idea of the lowlands versus the highlands.
There's some great animations where people will terraform Mars and fill it in with water, and you can kind of see.
So cool.
And the whole Tharsis bulge is just the last to go. Like that whole area is so high up over the compared to the rest of the planet that it takes a long time to fill in with the water. Um, Preston Pendergraft asks, "How are the volcanoes on Mars similar to the ones on the Moon?"
Uh, Very similar, different compositionally, but I mean they're both shield volcanoes. They're just much smaller on the moon. Baby little shield volcanoes on the moon.
Aw.
Baby cute little shield volcanoes. The ones on the moon are a lot more like the ones I believe that are in Arkansas.
Let's see. Aw, thanks, Dane. Uh,
Oh yeah, that's a good comment I saw.
okay. I think we're done. I think we need to wrap this up. We've
My
reached the end of
dog
our
can go to
hour.
the dog park while there's still daylight.
Oh, he knows. He knows it's time. Well, hey, thanks for an awesome 2016. Here's to a super fun, epic 2017 with an eclipse
Cheers.
in our future. Our first total solar eclipse
Yes, may we not be rained upon.
for all of us. So
So
again, if you're not
let's
if
nope out 2016 and make 2017 better because it's not going to be better unless we make it that way.
that sounds great. All right, thanks everyone. Thanks Pamela. We'll see you all next year. I'm gonna say goodbye now, and I'm gonna stop the stream. Well, apparently I cut the stream too quickly, but then I can't. How do I do this? How do I stop the stream if I don't stop talking? I'm just gonna stop
I
right now. We're just gonna
okay.
wave.